Let us start solving today's LeetCode POTD problem, Snakes and Ladders, which is a medium problem. Now, let us see what is given in the question. So, we are given with n by n integer matrix board. Okay, n by n integer matrix board. Now, in a Boostro-Fidon style, starting from bottom left to the board n minus 1 comma 0 and alternating direction each row. Now, if I have to say what is this Boostro-Fidon style, which is nothing but 1, 2, 3, 4. If it is a 4 by 4 matrix, let us take an example 1, 2, 3, 4 and then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now the problem is not how we solve this problem, but how do you get the index or the row and the column of a number. That's the main part and the main intuition for this question. Now let us see what we actually have to do to solve this problem. You start at square one of the board, which is nothing but here, bottom left. And in each move starting from square, current curr is nothing but current now is 1. Do the following. So choose a destination square next with a label in the range current plus 1 minimum of current plus 6 comma n square, which is this is not n2, it is n square. Now this choice simulates the result of a standard six-sided die roll, right? There are always at most 6 destinations. Now what is this telling is nothing but current. We are at current. Let us assume current is nothing but 1. Now with the current I can go to current plus 1, right? Only if this name it as current plus 1, name it as next. Now the next can go to current plus 1 or current plus 2 and so on, but it should not exceed n square, should not be greater than n square. Why? Because there are only n square is the last number that I can go. And now let us assume our current is 1. Now I can go to 2, 3, 4, 5, 6 and 7. I can't go to 8. Why? Because a dice can get 1, 2 and 3 and then 4 and then 5 and 6, right? That's all right. So that's what this die can do. It can go 1, 2, 3, 4, 5, 6, right? Okay. Now the current can be incremented by 1, 2, 3, 4, 5 or 6, right? So I'll just making this out, right? I need a loop for int I is equal to 1 till 6 and I will add this to the current plus I and I will name it as next. I will go to this next. So the half of the problem is completed. Now let us go. How can we get the matrix? But before that, matrix row and column. But before that, let us see. Always at most 6 destination if next has a snake or ladder. This is the most important thing. You must move to the destination of that snake or ladder. Otherwise, you move to next. The game ends when you reach the square n2. The game ends when you reach the square n square. Sorry, that means here it can be at the here or else it can be here. Now let us see where how can I get a snake or ladder. So if board of RC row column here, right, this is the row and this is the column. If it is not equal to -1, the destination of that snake or ladder is board RC. That means here if I say 1, 2, 3, 4, here I am naming it as -1 everywhere, -1, but here if I say if I need something like 10, if I say I have 10 here, -1, -1. Now I can go, when I get to here I will go to 10. Now the problem is where does this 10 lies. So if I rewrite it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 is just above this. Now how do we know that 10 is here and 9 is here, 2 is here, 6 and all these numbers? We'll be going to that in a few seconds. Now the destination and squares 1. So squares 1 and n square are not the starting points of any snake or ladder. So that means the n square will be always minus 1 and the starting point will be always minus 1. These are not any starting points of any snake or ladder. Note that you only take a snake or ladder at most once per dice roll. If the destination to a snake or ladder is the start of another snake or ladder, you do not follow the subsequent snake or ladder. Just say that here, from here, I get to this cell or box square. Now here I got another snake, right? And this is pointing to here. Now I do not go to this and execute it. Instead, I will go current plus 1 and going till 1 to 6. I will move the dice again. I'll roll the dice again. Why? Why? Because they said that note that you only take a snake or ladder at most once per dice roll. If the destination to a snake or ladder is the start of snake or ladder, so the destination is a start of another snake. So I don't take it. For example, suppose the board is something like here it is. So your destination is 2. You follow the ladder to square 2, but do not follow the subsequent ladder to 4. Return the least number of dice rolls required to reach the square n square. If it is not possible, return minus 1. Now, the first problem is how we get the row and the column. And the second problem is how can we execute and get minimum dice rolls. This is the second problem. Now let us go to the first problem. How do you get the row and column? Now let us take the first example which is given to us. Now what I'll do is just take this one and let us start with the row. How do you get the row, right? So let us start with this. Here I got 1, 2, 3, 4, 5, 6. Now this is at the row 0 from bottom, right? From bottom I am having the row 0. Now let us see. Here 1 by 6 will give us 0. 2 by 6 will also give us 0. 3 by 6 will also give us 0. 4 and 5 will also give us 0. But 6 by 6 is giving us 1. So to break this, what I'll do is n minus 1, sorry, num minus 1 by n. Num is nothing but the number which we got, right? 1, 2, 3, 4, 5 or 6 by n will give us row from bottom. I think it's clear. Let us check for the last row, 36, 35 and so on. So 31 minus 1 by 6 will give us 30 by 6 which is 5. 0, 1, 2, 3, 4, 5. Okay, but actual rows are 0, 1, 2, 3, 4, 5. Now 5 minus 5 will give us 0. So if I do 5 minus row from bottom, it will give me actual row. So but 5 is the not the number which I am looking for. 6 minus 1 which is nothing but n minus 1 minus row from bottom will give me the actual row. Now I got the row. Now I need what is the column. How do I get the column? Now let us see. Let us take 35 and let us take 29. Now, how do we get the column? 0, 1, 2, 3, 4, 5. Okay, but when I go to the column, it is not something like from left to right everywhere, but instead it is something like from left to right and then right to left, left to right and then right to left, left to right and then right to left. Let me remember this pattern, left to right and then right to left. But if I say this is at the row from bottom, which is 0, 1, 2, 3, 4, 5. Now when it is even, it is going from left to right. When it is odd, it is going from right to left. It is clear, right? Okay. If I take 35 and I need the column for it, I need where this column is present. For 35, I'm getting 1. Okay. Now 35 is divided with something like n, which is the only thing we need to divide it. Now if I take mod n, why we are taking mod n? Why? Because we only need 5 numbers, right? The 30 is already below that actual. We need the column from left or else from the right. For that I am just taking 35 mod n. But should I take 35 mod n? If I take 35 mod n, I need to go 5 places after. But what I'll take is 35 minus 1 mod n. Why? I'll tell you. If I take 36, I need to go for 35. Why? Why? Because here it will be at index of 5, 4, 3, 2, 1, 0. That's why I am taking n num minus 1 mod n. Okay, for now it's clear. Mod n is giving me 4, right? So it is the same thing which I placed here, 4. But is it the same every time? No. 29 minus 1 mod n will be, it is something like, it is giving me at something like 4, right? It is giving me 4. Now 29 minus 1 is 28. 28 mod n is also 4. So what I'll do is just name it as offset. I'll just name it as offset. Now when it is row from bottom is odd, what is it doing? It is just telling it is 1. Now when it is even, row from bottom is even, what it is saying? It is saying it is actually equal to the offset, right? It is actually equal to offset, but here it is not equal to offset. It is indeed n minus 1 minus offset. Let me check. 6 minus 1 minus 4 will give us 6 minus 5, 5 minus 4, 1. That's it. So let me just write it. Num, just take it num, and I am taking n. Just take something like something that get indices or something row and column. Now let me take row from bottom is equal to num minus 1 by n. Now offset, instead let us just take the row is equal to n minus 1 minus row from bottom. Okay, now column, instead of column, let me write what is offset. Offset is n minus 1 mod, sorry, num minus 1 mod n. Now we got offset. If row from bottom is mod 2 is equal to 0, let us see what happens. First thing, column is equal to row from bottom mod 2 is equal to 0. What if it is even? So if it is odd, something like here, but if it is even, just take offset as it is. But if it is odd, n minus 1 minus offset. So if it is even, just take offset as it is. Now if it is odd, n minus 1 minus offset. That's it. That's how you get row and column. Now let us go and solve this. How can we get this thing actually, right? When I start with 1 and my dice says 1 and 1 plus 1 is 2 and 2 is saying that 15. Now at 15 I just got with just 1. So from 2 I can just go to 15. So I can go to 15 with just 1 move. I am starting with 1 with just 0 moves. So in this way, let us get a queue, and let me also get something like visited array, which stores from 1 to 36. And I am just taking this visited array and making it as true. 1 is made as true. That means 1 is already visited. Now from 1, where I can go? I can go to 2, 3, 4, 5, 6 and 7. Now as I say 2, but it is not indeed 2, right? So if I go to 2, what is it making me to travel, right? Where it is dropping me from 2, it is dropping me to 15. So from just let me take a cube, right? So I am starting at 1 with 0 moves. Now it is visiting, right? It is traversing. From 1 I can go to 2, 3, 4, 5, 6. But when I got to 2, it is making me to land at 15. So I'll just write 15 comma 1. Now I have 3. So I'll write 3 comma 1, 4 comma 1, and then 5 comma 1, 6 comma 1, 7 comma 1. Now, what I'll do is just take this 15 comma 1. Let me take this 15 comma 1. Right. From 15, where I can go, I got 15, 3, 4, 5, 6, and 7. What I'll do is just mark them listed 15, 3, 4, 5, 6, and then 7. Now, I got 15 to traverse. So, from 15, where I can go 16, 17, 18, 19, 20, 21. I'll write it 16. Instead, I can write it over here. But let me wait and see is there anything. Yes. From 17, instead of writing 17, I'll write 13 with the number of moves. So 16, comma 13, 18, 16, 13, 18, 19, 20, 21. So 16 with how many moves? 2 moves. 13, 2, 17, 2, 18, 2, 19, 2. Here I got something like from 16, 17, 18, 19, 20, 21. So I got till 21 comma 2, 21 comma 2. So 17, 18, 19, 20, 21. So 16, 17, 18, 19. Sorry, here it will be instead of 17, I got 13, right? Now I have visited 15 successfully, right? I need to make this as marked 16, 13, 18, 16, 13, 18, 19, 20, 21, 19, 20, 21. Now 3 comma 1. Let us go to 3 comma 1 where I can go 4, 5, 6, 7, 8, 9. So at 3 I got only one move. 4 is already visited, right? It is already visited. No need to visit again. 5 is already visited. 6 and 7 are also visited. I just need to visit 8 and 9 comma 2. Okay, 3 comma 1 is also visited. 4 comma 1. Let us go to 4 comma 1. I can go 5, 6, 7, 8, 9, 10. Okay, 5, 6, 7. Now 8 and 9 are also visited, right? 8 and 9 are also visited. Now 4. At 4 I am just going 5, 6, 7, 8, 9, and 10. Right, if you see 10 comma 2. Now let me mark 10 is also visited. Now 5 comma 1. Let us just start with 5 comma 1. 6, 7, 8, 9, 10, 11. Now 6, 7, 8, 9, 10 are also visited. Now I have only one element which is not visited, 11 comma 2. Now I have 6. From 6 I can go 7, 8, 9, 10, 11, 12. But 7, 8, 9, 10 are also visited and 11 is also visited right from here. And I got only one element which is not visited, 12. So 12 comma 2 and let me mark it as visited. Now I have the next element in the queue is 7. Now 7 comma 1. Let us see. From 7 comma 1 I can go to 8, 9, 10, 11, 12 and then 13. 8, 9, 10, 11, 12 and 13 is also visited. So no need to visit again. Now I'm at 16 comma 2. Let us see. At 16 comma 2 I can go to 17 and when I go to 17 it is dropping me at 13 but 13 is also visited right. Now at 18 is it 18 visited? Yes. 19 visited. 20 is also visited. 21 is also visited but there is only one element which is not visited, 22. So 22 comma 3 is the only unvisited element, 22. Now let me go to the another element, 13 comma 2. So at 13 I can go to 14, right? 14 I am landing at 35. Now 35 comma 3, right? 15, 16, 17, 18, 19 are the next 5 elements. At 15 is it visited? Yes, 15 is visited. 16 is also visited. 17, I am going to 13 and 13 is also visited. And 18, is it visited? 18 is visited and 19 is also visited. So no need to go to any element. 18. Let us see. At 18, I have 19, 20, 21, 22. Let us see. At 18, 19, 20, 21, 22 and 23, 24. Let us see. 22, 23, 24 all not visited. 23 comma 3, 24 comma 3. Now let me go to 19 comma 2. Now 23 and 24 visited. Now 19 comma 2. 19 I can go to 20, 21, 22, 23, 24 and 25. But these 5 are also visited. Now 25 is the only element which is not visited. 25 comma 3. So let me mark 25 as visited. Now I have the next element as 19. So 19 is visited, right? 20 comma 2. 20. I can go 21, 22, 23. 24, 25 and the 26 is the only element which is not visited. 26 comma 3. Now it is the one which we traversed. Now 26 is visited. Now 21. If I start with 21, 22, 23, 24, 25, 26, 27. So 26 till 26 we have visited. Now I have 27 comma 3, right? 27 is visited. Now I have 8 comma 2. Now here I got 8 comma 2. Now I got 9, 10, 11, 12, 13 and 14. All of them are visited. 9 to 14 are all are visited. Now 9 comma 2. Let us go to 9 comma 2. At 9 comma 2 I can go till 15 and till 15 everything is visited. I can go to 10 and 10 I can go to 16, right? Let us see. Till 16 everything is visited. No need to traverse it. From 11 I can go till 17, but 17 is the only element which is not visited. So 17 comma 3. Now at 12 I can go till 18, but till 18 everything is visited. Now at 22 comma 3. At 22 comma 3 I can go till 22 plus 6 is 28, but till 28 only 28 is the missing element which I will go, right? And it is visited. 28 is visited. Now I have 35 comma 3. At 35 I can go to only one element which is 36. So 36 comma 4, here it will be our answer, but we are not done yet. 23, right? 23 plus 6 is 29, but 29 is the element which we not visited. 29 comma 4. Now 24 comma 3. Now let me see that do I have any snake or ladder at 29? No. So at that moment of time, no need to just go with any other element. Just go to the element which is there itself. Now I have 24, but 24 plus 6 is 30. Till 30 only 30 is the element which is not visited. So 30 comma 4. So 30 is also visited. Now I have 25. 25 plus 6 is 31. Now till 31 only 31 is the element which is not visited. 31 comma 4. Now 26 plus 6 is 32. 32 is the only element which is not visited. So 32 comma 4 and 32 will be marked as visited, right? Here 33 it is. Now 27 plus 6 is 33, right? So 33 is the only element which is not visited. 33 comma 4 and it is moved from the queue. And 30, let us go to 17 comma 3, right? 17 comma 3 I got, right, to go to 18, 19, 20, 21, 22 and 23, but all of them are already visited, so no need. At 28 I can go. At 28 I can go to 29, 30, 31, 32, 33, 34, but all of them are visited, but 34 is the only element which is not visited. So 34 comma 4 and I got 36 comma 4. At this moment of time I got to n square and I will return how many number of moves I got. Now this is a simple thing, right? What I am doing is just taking a queue of pair int comma int. The first one stores the position, right? It stores the position and it stores the number of moves. And first thing I'll do is q dot push. The first position is 1 and the number of moves are 0. And while queue is not empty, I need to do something. First thing is what I need to do is auto current comma moves is equal to q dot friend, and I'll remove that from the queue. Now there might be a chance that current will be n square, that is the end case, right? If current is equal to n square, then we need to return the number of moves there itself. Now for int dice is equal to 1 to 6, what I'll do is next is equal to current plus dice. Now this should be lesser than or equal to n square. Let me just take this. Next is less than or equal to n square. If it is less than or equal to n square, now I will get the next as let me take this as auto row comma column is equal to some function that I'll write and next comma n. So this function is nothing but get row and column. Now RC will get the where I got this next. Now if this is the next thing, right? So next is less than or equal to n square. Now if the next is not visited, then what I'll do is visited of next is equal to true. Visited of next is equal to true, and q dot push next comma moves plus 1. That's what I did here. I just made the next to be pushed back with the number of moves incremented by 1. That's it. And at the last return -1 if we didn't get n square as the current. So this is how the BFS algorithm works, and I have given the code link in the description. Go and check it, and if you have any doubts, go and comment in the comment section and I will reply you in just 2 to 3 hours. And if you like this video, do share it with your friends and do subscribe to my channel. Thank you.